Hello. In this video, we're going to talk about how to build a slightly more visual representation of data called a relative frequency histogram. And a relative frequency histogram is for quantitative data, right? So it's for data that has a very numerical sense, where it's a type of bar graph where the height is going to represent the relative frequency or the how often each measurement falls into what we call a class. And a class is really nothing more than a subinterval that contains specific ranges of values, right? There's a lot of class terminology when we talk about relative frequency histograms because we want to build this in a very robust way. So let's get into some of this terminology. The first is what we call a lower class limit. And because these classes are ranges of values, there's going to be a lower limit and an upper limit for every class. So a lower class limit will be the smallest numbers that belong to each class. Likewise, the upper class limits are going to be the largest numbers that belong to each class. This is not just one thing. There is a lower class limit for every class we have, and there is an upper class limit for every class we have. Next, we want to talk about class boundaries and class midpoints. These are values that really kind of work when we talk about the histogram. We tend to focus on class boundaries, and these are values that are used to separate classes, but without the gaps that are technically created by class limits. And what we mean by that is oftentimes when we build this, and you'll see an example when we do build this, we'll get an upper class limit of, let's say, 39. And the next lower class limit is 40. If we were to build a relative frequency histogram, what number would we put on this number line to mark off our bar chart? And the answer is we really don't want to put 39 or 40 on that bar chart. The reason is we want to make sure that if we're going to build this specific type of bar chart, we put a value that's not contained necessarily in every interval. And so technically what we do to build these class boundaries is we take kind of what's in between those two. So 39 and 40, halfway in between that is 39.5. That is going to be the class boundary that separates this class which has an upper limit of 39 and the other class which has a lower limit of 40. A class midpoint is just going to be the middle of the class, kind of the upper value plus the lower value divided by 2. The last piece of terminology we want is what we call a class width. And a class width is just going to be the difference between two consecutive lower limits or the difference between two consecutive upper limits, right? We do not take the upper minus the lower, right? That's not how we find the class width. We take the difference between two consecutive lower limits or two consecutive upper limits. Okay, so let's talk about how we actually build this histogram, these relative frequency histograms. And so first, we have to build the relative frequency distribution. That's kind of the first thing we need to do. We need to build a distribution. The issue is we talked about having quantitative data by building dot plots or stem plots, and that relative frequency distribution was really kind of reserved for qualitative data. We're gonna take that same idea and build a relative frequency distribution for numeric data. So the first thing we're going to do is we want to divide the data into about 5 to 12 classes. Typically, in this case, I will be the one to tell you how many classes there are. We don't want to be grading like a whole bunch of different things. I don't want one student to build 5 classes, another student to build 7 classes. Those will be vastly different answers. So typically we use 5 to 12 classes. That kind of strikes a good balance between being really precise and being presentable in terms of our data. What we need to do to build these classes then is calculate a width of our class, right? We want to build the class width. And we do this by taking the range of our data, kind of the lowest value and the highest value, right? The highest minus the lowest, and divide it by the number of classes. And the key is we want to round it to a convenient value. Oftentimes, this is going to be a decimal, and we don't want a decimal for class width. We always kind of want a whole number, so we want to round to a convenient value. Third, we're going to build the class limits one at a time. So we're going to build all of the lower class limits by choosing a limit smaller than a value and then adding all of the class widths. And then we can find all the upper class limits by the next class's lower limits or by the class widths. And this will be easier when we actually build one to see exactly how we're going to do this. 5, we can actually create the distribution by including the classes, by looking at the classes in the table, doing the frequency and then the relative frequency. So we're going to count them. We know what the total should be, and we'll find the relative frequency. Finally, we're going to build or draw this histogram by plotting the classes on a horizontal axis by class boundaries, and then using the heights to distinguish what bars we have for our histogram. So let's build this. We're going to build a relative frequency distribution and histogram for the following data set of values. So what we'll do is we're going to pick 6 subintervals to partition these 50 data points into. So if I look at our data chart, our highest value is 70, and our lowest value is going to be 26. So when we build our classes, the first thing we need to do is look at a class width. And our class width, again, is going to be the range divided by the number of classes. In this case, the highest data point there is 70. Our lowest data point there is 26. We said we want to divide it into 6 classes. And we get something like 7.33. Now, it doesn't make sense to build a class width that's a decimal length. So what we'll do is we'll round this. We typically round this up to 8, right? 8 is what our class width will be, a nice integer value that I can add to everything. So with that in mind, we want to build our classes, right? Here is kind of a very basic table that we'll build our relative frequency distribution for in an effort to build our histogram. So we need to start with the first lower class limit. And since our initial value was 26, we want to pick something just smaller than that. 25 seems to be a good value, right? And what we're not going to do is we're not going to build this upper limit first, right? The instruction said we want to build the next lower class limit by adding our width to this. So if I start at 25, I want to add 8. And if I add 8, I'll get 33. Likewise, 41, keep adding 8, 49, 57, and 65. Those will be all of our upper class limits. I'm sorry, all of our lower class limits. To find our upper class limits, if I know this lower class limit is 33, this upper class limit has to be 32, right? These classes are designed to kind of butt up right next to each other. And so I can find the next upper class limit by just adding 8 to my first class limit. So I'll get 40, 48, 56, 64, and 72. Right? Our classes, again, are ranges of values. And so what we want to do with these ranges is look at our data set and count for every data point. So for 34, for 34, I want to say, where does 34 fit in these classes? Well, 34 falls somewhere between 33 and 40, so I'll put a tally there so that there's at least one data point in that set. I look, my next data point is 48. Where does 48 belong? It belongs right here. It is the upper class limit, so it belongs there. And we do this for every piece of data we have. And if we did that, I have tallied these up. This would take way too long to try and tally up on the spot. Right? You can pause the video, look at the data set, and see if that's correct. That is correct. And so the tally is just a good way for us to count, right? It is kind of hard to just look at a class and say, okay, I'm only going to consider the values between 25 and 32 and try and cancel out values. That is really hard to do. I prefer to tally. So that way I can I can look at the data points kind of one by one, say, I got that data point, I got that data point, got that, got that, got that. And I'm putting the tallies in the appropriate classes. Then I can just say, okay, the frequency that class appears is 5, 14, 13, 9, 7, and 2. And because there's 50 pieces of data, I know my relative frequency is going to be 5 over 50, 14 over 50, 13 over 50, 9 over 50, 7 over 50, and 2 over 50. One thing we want to note when we're building this relative frequency is that I'm not getting a common denominator, or I'm sorry, I am leaving it in terms of a common denominator. I'm not reducing, right? This 5 over 50 could technically reduce to 1 over 10. The problem is not all of these things do reduce. 13 over 50, 7 over 50, that doesn't reduce. And what we want to turn this into is we eventually want to turn this into a height value. And it's very difficult with fractions to determine, well, is 1 over 10 and 9 over 50, which one is necessarily bigger? Or if I reduced 14 over 50 to 7 over 25, and if I looked at these two values, 7 over 25 and 13 over 50, it might be hard to tell which one is bigger than the other. Whereas if I leave with the same denominator, all over 50, I know exactly which is the biggest, right? This is now the biggest set, followed by this class, and so on and so forth. So to build this histogram, we're going to need the values, these class boundaries, on the horizontal axis, right? And we're not going to find all of them this way. We've seen that there's a pattern, right? That the difference between the upper limit of one class and the upper limit of the other class is our class width of 9. If we could just find one class boundary, then we could just add our class width of 8 and get the next class boundary. So if we look at the lower limit of the second class, which is 33, and the upper limit of all first class, which is 32, the class boundary point is going to be somewhere in between there, exactly halfway in between there, which is 32.5, right? Which makes this class boundary 40.5 and 48.5 and 56.5 and 64.5. Now, what we also want to include, right, if we look at this class right here, that first value is 25. There is no other class to the left of 25. But what we can still do is take the class width here of 8 and subtract it and get 24.5 to kind of be a starting class boundary for the first class. Likewise, if we roll up, this class has an upper limit of 72. It is the largest class. There is no data point bigger than 72. But what we can do is have an upper boundary, kind of a class boundary on the right there of 72.5. And so what we do is we'll plot all of those values as our x-axis right here, right? We'll have 24.5, 32.5, 40.5, and so on. And so I know anything that falls here has to fall in the first class. Because if all of our values are integers, they kind of just have to fall there. So if we remember, that first class was 5/50ths, right? Our y-axis, we just need to go up as far as our data point goes. So it goes all the way up to 14/50. We don't need to go all the way up to 15/50, right? The highest thing we have is 14, so we can just go there. So 5/50. So we'll do that. What is unique about a histogram is the bars in our bar charts butt up right next to each other, right? There's no separation, which is why we use these boundary points, because there is no inherent separation in that. So the next class, right? The second class had a frequency of 14/50. We just kind of extend the right side of that and then come down. The next one was 13/50. And then 9/50. It's going to be about there. And then I believe it was 7/50. Yeah. 7, which is going to be about there. And then 2/50, which is there. And then typically we shade them in. I don't need you to necessarily shade a whole lot. This is sufficient shading. And that is how we build a relative frequency histogram, right? We build the distribution up here, right? We build a distribution just like we would have in the previous video. And now we take our relative frequency and we put it in terms of a bar chart where our bars are squished together and the x-axis are these class boundaries, kind of these halfway in between points. All right. Hopefully this is helpful. If you have any questions, let me know. I'll see you guys next time.